Four main types of non-contact, air-based haptic methods currently exist: ultrasonic phased arrays, fans, compressed air pneumatics, and vortex cannons. In this work, we explore a new approach for mid-air haptic feedback using synthetic jets, or SINJets for short. These simple, low-cost devices are able to generate high-velocity, coherent streams of air on their outward stroke, but ingest ambient air from all directions on their inward stroke, resulting in a net zero mass but significant momentum flux. With the right combination of stroke displacement, port geometry, and drive frequency, a jet of air is emitted. Note that unlike conventional air jets that require a compressed source, either a pump or tank, SINJets are self-contained and can be made in a wide range of sizes, tailored to different use cases, and capable of haptic effects both small and large. Using a CNC apparatus to capture and then visualize air pressure and flow, we studied how SINJets could be manipulated for expressive haptic purposes. Controlling basic parameters such as frequency, amplitude, and duration, we can create different flow modes such as continuous jets, modulated jets, and impulses. We also built prototypes able to vary their nozzle aperture and thus jet geometry, as well as steer their flow, opening the door to both spatial and time-varying effects. We built a series of example devices to illustrate the broad utility, feasibility, and scalability of our approach. Starting small, we created AR glasses with two double-ported haptic SINJets. A variety of stimuli are possible. For example, sharp pulses firing from all ports for notifications or swiping animations for wayfinding. In this VR headset demo, 6 small haptic SINJets work together to render haptic animations onto the sensitive skin of the face. For instance, in this city simulator, a directional splash is created from a car driving through a puddle, while a face-wide impulse is triggered as the user crashes into a pole. In this desktop computing setup, an augmented keyboard contains a 2x4 array of haptic SINJets. This can provide both keyboard haptics as well as supporting haptics for touchscreen interactions. For example, if there's an error message, the user feels a strong mid-air vibratory pulse. Or, when a button is pressed on the touchscreen, the keyboard emits a click-like impulse. Likewise, when the user sends an email, a lateral swoosh effect is rendered onto the hand. Haptic SINJets could also be incorporated into screenless devices, such as the smart speaker. Using a time-of-flight rangefinder to track hand height, we can provide a clicking sensation for an in-air confirmation button, or in-air detents when setting a continuous value, such as volume. Mid-air haptics is often coupled with applications employing free space hand input. Here, we utilize a dynamic nozzle to vary the thickness of the jet stream to convey the zoom level. We also created a steerable haptic SINJet. In the future, this could be integrated into the dashboard of a car to support spatial tasks. Such a device could be used for blind spot monitoring, hazard alerting, incoming phone calls, drowsiness prevention, and more. Finally, we created a very large demo capable of emitting powerful haptic effects at longer ranges. This could be used to haptically enhance television or console games with weather, heartbeat, projectiles, explosions, and other effects. Please see our paper for more details.